Hi, my name is John Straube, and I'm a professor at the University of Waterloo in Canada, and I've been involved in research about building performance for, 30 years or so. I got interested in buildings when I was a teenager, actually, and I started doing summer jobs working on construction sites. And I have to say that that was the best start that I think I could have had, is to be on the ground, literally in the trenches. I did a lot of basements, to understand the complexities, the interest and the excitement of working on homes, working on housing. I then chose to go to university, and the closest area study I could find that was connected to housing was civil engineering. I was a bit disappointed taking a civil engineering degree that we didn't spend a lot of time talking about buildings, and we certainly didn't spend a lot of time talking about building energy performance and home energy and so on. So it really took until graduate school before I stumbled upon somebody who knew what passive solar meant, and air tightness, and the balance of insulation and mechanical systems. And that's when I got really quite excited and discovered that this is what I wanted to do. And over the last 20 years, practicing, studying, researching in this area, and increasingly teaching it to students, I think I've found out that you can feel pretty good about yourself if you're working in the home energy business, because pretty much everybody you meet lives in a home. And pretty much everyone you meet, and even those you dislike, want to have a good home. That means comfortable, healthy, safe, and energy efficient. And so when you say that I work on making houses better, saving energy in buildings, avoiding mold and rain problems, it's actually something you can feel pretty proud about. And that's one of the nicest things about the area that I stumbled into / chose, is that almost everyone recognizes it as being a worthwhile endeavor. I'm not sure how I'd manage to be an attorney that does wrongful death suits or something like that. There'd be a lot of different responses. So I actually think that that's one reason why I can easily recommend people to get into the area of buildings and building performance. Something else, as I've wandered through the path of helping to figure out what it means to make good buildings and how to deliver them, is that you can't divorce the reality of how people use buildings and how people build buildings, how people operate buildings, and how people construct buildings from the science and the technology. And so that just naturally flowed from how I came into the business. And I really would think that some people don't understand that complexity. And although it's a bit quote unquote messy to have to deal with humans, it's also infinitely more interesting and infinitely more rewarding than having things that the only side of the problem is the technical, that you can model and calculate and get an outcome. In the building world, we really have to think a lot about the people, about the communities, about the cities they're in, and understand who's really making these buildings and who's really living in them. And that influences all of the science, that influences the technology that works and doesn't work. And so that makes it, to my mind, much more interesting and much more rewarding. So my work in the buildings world has really been started in energy. Back when I was 15 and 16, reading Popular Science and Popular Mechanics magazines, there was lots of articles about solar houses, double shell houses, super insulated houses. And these were all building techniques and technologies that were striving to have a very low energy footprint. And surprisingly, in 2016, we continue to see similar things posited. But when I looked at the energy side, I got directed into that research. I wanted to do energy-related research, and was surprised, when energy prices dropped through the floor. I began my graduate studies when oil was at $10 a barrel. And people said, oil will never be expensive again, and we can't, energy's cheap, and there's no real reason to worry about energy in houses, in buildings, in schools. Because I was interested in building performance, we responded to the more pressing need at the time, which was moisture problems. And so I spent at least 10 years both studying and practicing and solving moisture-related problems. And interestingly, I would say that still is mostly what I do, is solving mold, solving deterioration like freeze-thaw, rot, corrosion, and so on, all driven by moisture. That moisture side always is there. But luckily, in the last decade or so, there's been much more widespread interest again in energy. And this time, not just because energy is expensive, or not just because we might not always have cheap and plentiful energy available, but because it's become pretty obvious that the use of energy has consequences to the planet and hence to our neighbors and our family and our future. And that means that now we've gone full circle and now we do a lot more energy-related research. But the moisture side remains really important because we have learned from experience as an industry that you can't just save energy and not actually impact moisture. And similarly, you can't save energy and not consider comfort, or not consider safety, or not consider health. All of these things have to be dealt with as a holistic system. And so the concept of house as a system has been promoted for decades. And I think sometimes people forget about it in their excitement to say, I want to make a better insulated house. I want to make a house that's low energy. Yes, but we also have to make a house that is healthy, that is safe, that is affordable, that is constructible, that is maintainable. And that is, again, saving energy is easy. You just disconnect the utilities. But then you end up with a very uncomfortable, unsafe house that nobody wants. And so really the job is, and that's why it is such a large job that needs so many people for so long, is to actually balance out all of these competing interests and come up with the best way, often the best way for that locality, to achieve the right combination of energy efficiency and health and safety and durability and moisture resistance. So the future of the home energy, home performance, buildings area is going to be as turbulent and as exciting as I think the last 20 years have been. That's because we have a lot of existing buildings that haven't been touched, haven't been approached from a point of view of improving their durability, comfort, health, or safety. In fact, the majority of buildings in America right now, by far, don't have any sort of approach to energy efficiency or durability or safety. And so as time goes on and those buildings, A, get older and then need to be repaired and maintained, and B, as we set higher standards for new buildings, those older technology buildings will look like they're not as good because they're not as good. And so we will have a huge amount of work to be done, and it's meaningful work because it's such a large part of our demographics of buildings that we have to address these existing buildings. And this is going to take a lot of different thinking because when you have a clean slate of paper on a new design, it's actually relatively well understood what pathways one would take to make it be a good building. But when it comes to the existing buildings, gosh, there's just so many different ways of doing it. And so that means that your constraints when you start approaching that building are much more. You don't know that you have enough money to do a full deep energy retrofit. You may only have enough money to do a once over and come back in another 20 years. The different construction technologies that were very regional, that change with time, building materials that we actually don't understand very well because we haven't made them for 50 years, will be unearthed as we open up those buildings. And so in professional practice, we find that these retrofits are always more challenging because you don't have as much information and you don't have as much flexibility. And it takes a lot more of one-on-one action to decide you can't do this from an office, you have to be at the building. It's very difficult for people in Denver to do buildings in Bangor, Maine, without being in Bangor, Maine. And so this will mean that there's a lot of local business that needs to get the knowledge of the best knowledge in the nation, but apply it in each of their communities to deal with these retrofits, because each of these communities across America has different kinds of building construction, different kinds of constraints, different kinds of pressures. So the whole retrofit, the whole fixing up what we've already built, and I mean literally up until, there's going to be buildings built in 2010 that need retrofitting in the next 10 years. And that go and all the way back to buildings built in 1850 or earlier. And that's going to require a lot more understanding, a lot of hands-on work, and a lot of flexibility for the people who in the future are going to be working in saving energy in homes and making homes better.